Good morning. Uh, in this lecture, we are going to discuss about introduction to array, array declaration, array initialization, some of the concepts implementation using array. So, introduction to array. So, most of the time it is necessary to store and process large volume of the similar type of the data elements in a computer memory while solving complex problems. In that situation, we will use the concept of the array to handle large volume of the data, so which is similar. Let us consider some examples. Say I want to store and process the roll number of 100 students or 200 students or sometimes 1000 students and more than 1000 also. So here the roll number of the student is similar data type, so homogeneous data type. So this can be achieved, and this can be with the help of array, it will be very easy to handle such a data. So another example, assume I want to store average marks scored by 100 student. So the average marks is of type same here, similar data. So we are handling similar data type for 100 students. And another example is, say I want to maintain the details of salary of employees who are working in some organization. So here the salary data is of type same. So we are handling a data of some employees, say 100 or 200 employees. And last one is to store the details of the student. So to manage the details of the students, such as a roll number, university seat number, name of the student, course opted, and marks of and final marks of each and every student. So this can be handled very easily by using the concept of the array. So let us see what is the difference between a normal variable and array. A normal variable can be allocated in a memory in different location, so not consecutively. Suppose if we declare two variables at the same time, so one variable is allocated some other part of the memory and another variable could be allocated in another part of the memory. So no guarantee of consecutive allocation. So here the age is a variable and it is initialized with 20. So a memory will be allocated and this memory location is stored with the value 20. So coming to array, the memory locations are allocated in consecutive manner. So here you can see all these blocks represent individual memory locations, so which are consecutive, and all these contents are the elements of the consecutive memory locations, and these memory locations are represented by index value. So these are called as index value. So at index 3 represents this particular memory location. At index 3 we have a value 50. So what is an array? So let us define and give a proper definition for an array. So an array can be defined as collection of related elements, of similar data type stored in a computer memory consecutively. So whenever we declare the array, it means that we are handling a similar type of the data, and we are storing an information in contiguous manner. So here the data element can be processed by using common name. So every data which is stored in a array is accessed or represented by using common array name. Only indexes can be changed. So an array starts from 0 and ends with a array size -1 here. So here an example is taken. So this is the name of the array, this is a maximum size of the array, and this is the type of the data we store into the array elements. So this means that a is a array variable of type integer of maximum size is 8 here. Means from 0 to 8 nothing but it is 9. So 9 elements, 9 memory locations are consecutively allocated. So in this picture you can see, so these are the indexes of the array and these are the memory locations which holds an element of the and the length of the array is 9 here. See here a of 6 indicates 6th location, the value at index 6. So suppose if this index value is having a value 10, then 10 is accessed by using this particular statement. So we can store the element in array by following manner. So 10 can be stored at first location, 20, so on. So types of the array, there are array can be classified according to the volume of the data to be stored in computer memory. So it can be classified into 3 groups: one-dimensional array, two-dimensional array, and multi-dimensional array. So one-dimensional array will be having a single row. The two-dimensional array require row value as well as column value. So one-dimensional array is used to handle list of the elements, linear list of the elements, or sequence information, sequential information. Say for example, to store or to sort a number or to find a number in a list. For implementation of such a concepts, we'll use single dimensional array. A matrix multiplication handling the name and roll number associated data can be done by using two-dimensional array. So in case of three-dimensional array, 3 index values are required. So and that is declared by using this particular syntax. So let us discuss about one-dimensional array. So it is defined as a collection of related data elements used to store and process a linear list of the data element. So as I said already, a linear list of the data is nothing but say the name of the student, only the name of the student. So assume I want to sort the names which are present in a list. We suppose if we want to sort the list of the elements, I want to search an element present in a list. In such a situation, we'll use one-dimensional array. So let us discuss how to use one-dimensional array for the programming. So any concept, before using, we should know what is its syntax, and some rules and regulations, how it is initialized, how it is declared, like this. So a one-dimensional array can be declared by using following syntax: the data type, the array name, the size. The data type could be the integer, float, character, double, etc. The name of the array is any valid variable name. The size is nothing but the maximum number of the data elements that can be stored, and this must be integer. So let us consider few examples. So here int a of 5 has been declared. So here a is an array of type integer, 5 is the maximum size of the array. So whenever this declaration is encountered in a program execution, 5 consecutive memory locations will be allocated, and we can store the values in these memory locations. So here another variable is declared by name price of size 5, and it is of type float. So we can store 5 items price information, and one more variable, the result of size 5. So we can store the result of 5 students. So here a name array variable of type character means we can store 5 characters in this particular variable, and another array variable of type character, that is city, we can store 5 characters city name in this particular variable. So let us see next section, how to initialize an array. So we know already how to initialize a normal variable. An initialization is nothing but giving or assigning some initial values to the variable for the purpose of processing. So there are two types of initialization. One is compile time initialization, second one is runtime initialization. So this part we shall see in the next section. So let us discuss about how to initialize an array at compile time. So let us define what is this compile time array initialization. So in case of compile time array initialization, the assigning of the values will be done during the declaration of an array. So as soon as we declare an array, immediately the values will be assigned to the array variable, so that all those values can be stored in a respective memory locations. So here a syntax is followed: the data type, array name, and the size. So this part is declaration. So as soon as a declaration is completed, it is immediately initialized by passing the initial values which are separated by commas. So let us take an example. So here we have declared an array of name A of size 5 and of type integer, and immediately we are assigning the values. So the 10 will be stored in first location, 20 will be stored in second location, so on. The last value will be stored in fourth location, and all these values are continuously stored in a memory. Let us take few examples. So here the name is array of maximum size 5, and this is initialized with John. The first character is stored in first location, second is stored in second location, so on, and last location is filled with null character. So this indicates the end of the string. So we can also initialize character wise. So the first character is stored in first location, second character is stored in second location, third is stored in third location, next character is stored in third location, and so on. So here an array is declared of maximum size 5 of type character. Only one location is initialized, that is j, and rest remaining locations are filled with null character to indicate end of the string. So here integer array of type 5 and all locations are filled with 0. Here integer character, integer type array, and initialized with only 2 values. So the remaining locations filled with 0. And here an array is declared of size, maximum size is 3, but we are storing 5 values, so this is invalid. So let us see some programs implementation using an array. So here you have to implement a program to read 5 elements from the keyboard, and you have to store it in a computer memory consecutively, and you have to access those values and you have to display it on the screen. So whenever it comes a matter of storing an information consecutively in a memory, then array is a solution for and efficient for handling the data. So we have implemented this program by using array. So we are declaring an array of name a of type integer. The maximum size is 5, means 5 elements can be stored in a memory location, and one more variable I. So every time I will be incremented and it will be pointing to the memory locations to store the value and to read a value from the memory location. So this particular line will read a element from the keyboard and will store it in a computer memory. So here I value is 0, so I is less than 5, the condition is true, the control will enter into the loop. So here a of I is nothing but a of 0 means first location. So in first location, whatever the value entered by the user, that is stored. So again it will go back to the loop. I value is incremented by 1. So now I value is 1, 1 is less than 5, condition true. Again it will enter into the loop. So now a of 1 is nothing but the second location. So in second location, this second value entered from the keyboard will be stored, and this process will continue till I value is less than 5. So whenever the I value is 5, this condition will be failed and control will come out from the loop. So once after coming out from the loop, so we have to read each and every element of the consecutive memory location, and we have to access and we have to display it on the screen. So for this purpose we are writing these two instructions. Again we are initializing I value to 0. So 0 is less than 5, condition is true, it will enter into the loop. So a of 0 means this value. The content of a of 0 is 10, that is displayed on the screen. Again I value is incremented, so now I value is 2, 2 is less than 5. So a of 2 means the content of 1, a of 1 is nothing but 20, that is displayed on the screen. So this process will be continued till I value is 4. Whenever I value is 4, the content a of 4 is nothing but 50, that content is displayed on the screen. Whenever I value is 5, it will come out from the loop. So we shall implement one more program. So here you have to read 10 integer elements from the keyboard, and you have to store it in a computer memory continuously. You have to compute the sum of 10 numbers, calculate average, and you have to display sum and average here. So we are declaring a of 25. So here what happens, 25 consecutive memory locations will be allocated. So out of 25, 10 memory locations we are using in our program. So even you can also declare it as a of 10. So this variable will be pointing every time the index, array index, and this variable will store the sum, and this variable will store average. So we are asking the user to enter 10 numbers from the keyboard. So as usual, 10 numbers are stored in a memory location here, and after storing, each and every element is read from the memory location, and that is added with the sum. So once complete addition is performed of all the array elements, it will come out from the loop. So here an average will be computed, that is sum divided by 10. So this is called as typecasting. So the forcibly we are converting integer to float, because the average is of type what here, float here. So once after average is computed, we are displaying sum value and average value. So in next section we shall discuss about some of the sorting techniques and searching techniques, so which are implemented by using the concept of array. Thank you. So if you have liked this video, please subscribe to my channel for further videos on C programming concepts, and also write your valuable comment for further improvement, and also click on like button to if you have liked this video. Thank you.